Have you ever wondered why scientists classify elements? Imagine trying to navigate through a massive library with no system of organization. You'd be lost, right? The same applies to the world of elements. Classification provides a sense of order, turning what could be chaos into a comprehensible system. It's like a roadmap, guiding scientists to understand the properties of elements and how they react with each other. By observing patterns and trends in classified elements, scientists can predict behaviors and characteristics even before experiments are conducted. Beyond that, classification is a powerful tool for discovery. Just as an empty space on a bookshelf might suggest a missing book, gaps in the classification system hint at undiscovered elements. This has led to the prediction and eventual discovery of numerous elements, expanding our understanding of the universe. Indeed, without classification, the world of elements would be one big, confusing mess. But who started this elemental sorting game? Let's journey back to the early 19th century, to the laboratories of two pioneering scientists, Johann Dobereiner and John Newlands. Dobereiner was one of the first to attempt organizing elements, and he did so through what he called triads. In each triad, the middle element's properties were an average of the other two. This was a revolutionary concept, but it had its limitations, as not all elements fit neatly into these triads. Then came John Newlands, who proposed a different approach. He saw a pattern, a sort of music in the elements. He called it the law of octaves, arranging elements in such a way that every eighth element had similar properties. But again, this system had its flaws, as it only worked for the first 20 elements. While these were significant steps, they were just the beginning of the journey towards the modern periodic table. So, who took the next leap in the development of the periodic table? Enter Dmitri Mendeleev, a Russian chemist who was nothing short of a visionary. He was the one who put forth the concept of the periodic law, stating that the properties of elements are a periodic function of their atomic weights. But what made Mendeleev's approach truly remarkable was his bold move of leaving gaps in his table. Yes, you heard it right. He intentionally left spaces for elements that were yet to be discovered. He had such unwavering faith in his theory that he even predicted the properties of these undiscovered elements. And guess what? His predictions came true. The discovery of gallium and germanium, fitting perfectly into the gaps he left, was a testament to his foresight and the accuracy of his periodic law. Mendeleev's table was a great leap forward, but it had its limitations. But that's a story for the next scene. Stay tuned. How did we end up with the periodic table we see today? The answer to that takes us to the early 20th century, when a British scientist named Henry Moseley made a groundbreaking discovery. Moseley found that each element's identity is uniquely determined by the number of protons it has, not by its atomic weight, as Mendeleev had proposed. This number, known as the atomic number, became the basis for the modern periodic table. Moseley's work ironed out the inconsistencies of Mendeleev's table and paved the way for the discovery of even more elements. The modern periodic table is now arranged by increasing atomic number, which gives rise to a series of patterns called periodic trends. These trends reveal the behaviors of elements and help scientists predict how they will react under different conditions. The transition to this new arrangement was a game changer in the world of chemistry. And that's how we arrived at the modern periodic table, a testament to scientific progress and collaboration. Isn't it fascinating how the periodic table has evolved over time? We've embarked on a journey through history, watched the birth of classification, and seen the audacious moves of Mendeleev. We've witnessed the gradual transformation into the modern periodic table that we know and love today. The periodic table isn't just a chart, it's a map. A map that guides us through the complex world of elements. It's a tool that helps us understand the behavior of elements, their similarities, differences, and their relationships. It's like a puzzle where every piece, every element, has its rightful place. This understanding goes beyond the classroom. It's the foundation of many scientific discoveries and innovations. So the next time you look at the periodic table, remember it's not just a table, it's a story of discovery, of science, and of our universe. Thank you for joining us on this journey through the development of the periodic table. Don't forget to like, share and subscribe to Facts Academy 0122. And do leave your thoughts in the comments below. Until next time, keep exploring.